Good day and welcome all to another training module from Operators Unlimited. I am David Collier. My contact information is on the right side of your screen, so if you wish to send me a question or a comment, please feel free. In this module, I'm going to talk about laboratory. I am discussing the general ins and outs of a laboratory. Your site or organization may have special details not included in this presentation. So as part of this review, we're going to talk about what is the purpose and the goal of a wastewater treatment laboratory. Our goal is to guide the daily operation of the wastewater treatment facility through water quality checks and to prove proper operations to the governing agencies with certified sample analysis. We're going to talk about laboratory operations, the lab equipment, the procedures, and the samples. Let's start out with safety. All safety procedures should be practiced. Use proper PPE while collecting and processing all of your samples. Personal hygiene and neatness are critical, keeping things clean and organized. All chemical containers should be labeled. Chemicals should be stored in the proper storage lockers. So we're going to talk about some types of glassware now. A pipette marked with the TD on it means it is to deliver. A pipette marked with the TC on it means to contain. A pipette with a bulb and one graduation mark for a specific volume is a volumetric pipette. A pipette marked with A, that means grade A, and it's the most accurate. Beakers and flasks are used for mixing and heating of known volumes of liquid. In a ranking of accuracy, the most accurate is a pipette, then a graduated cylinder, then a beaker, and last but not least, a flask. All glassware must be clean. Dirty glassware means inaccurate analysis. Graduated cylinders should be read from the bottom of the meniscus. The curve at the top of the water column is the meniscus. Some types of equipment we're going to talk about here. Procedures should be in place for daily equipment checks, calibrations, and documentation. Procedures should also be in place for the proper use of all laboratory equipment. In the laboratory, if something takes place but is not documented, it did not happen, so be vigilant with documentation. Lab employees must be trained on all equipment procedures before performing analytical activities independently. The oven is used for TSS, mixed liquor suspended solid samples, and is set to 104 degrees C. Don't forget to document this. The muffle furnace is used for MLVSS, mixed liquor volatile suspended solids, and is set to 550 degrees C. Again, don't forget this documentation. The desiccator is used to cool samples after they have been cooked in the oven or furnace. These samples should be cooled for 15 to 20 minutes in a moisture-free environment. The filter pads should be stored in the desiccator to keep them dry. Also, avoid handling the pads with bare hands. The laboratory scales should be calibrated and or verified each day with a certified set of weights. Documentation. Don't forget to document. Lab pH meters should be cleaned and calibrated each day using buffer fluids that are current, within date. Again, document this. The lab refrigerator should be checked for its temperature each day and documented 4 to 6 degrees Celsius. The incubator is used for BOD samples. Okay, it is set at 20 degrees C. I've got there for 5 days. You're going to incubate your sample for 5 days. So don't forget to document your temperature each day or the test will be void. Maintain your fume hoods. The mechanical aspect and cleanliness needs to be maintained. Do not store chemicals in the fume hood. Maintain that cleanliness. Chemical reagents should be stored in the chemical lockers. Maintain your safety showers and eye washes just in case there's an accident. Document the inspections. Chemical names and formulas. In the lab, everything isn't spelled out like you would hope. Sometimes there are codes used. Okay. Elements make up compounds. Elements are the most basic unit. Okay, so an O equals oxygen and H equals hydrogen. A compound is made up of elements and the compound is a pure substance. So H2O, so you got hydrogen and oxygen. H2O equals water. You also have units of normality. So that is a slanted N, and that is the acidic or the basic strength. So if you are going to have 0.02 N H2SO4, that is sulfuric acid with a strength of 0.02 normality. It's a very weak sulfuric acid. Molar weight is a slanted M or moles per liter. This is a molecular weight in grams. In a lab, you're going to have to mix up liquid solutions from time to time. So liquid reagents are mixed on a volume to volume basis as opposed to a mass per volume. Okay? So if you're using dry ingredients, you're going to use the mass per volume, which is milligrams per liter. But on a liquid reagent, it's going to be volume to volume. The dilution ratio is written as 1 to 5 or 1 to 10. The first number is the volume of the concentrated liquid. The second number is the dilution. That's your deionized water. So the unknown volume of the water is X, the unknown. So 1 to X or 1 plus X. And it's stated as just that, 1 to X or 1 plus X. This means mix 1 volume of concentrated liquid that you want to dilute with the unknown, the X volume of distilled water. An example here is 1 to 5 or 1 plus 5. Okay, so 1 to 5 means we're doing sulfuric acid. So 1 volume of H2SO4 is mixed with 5 volumes of distilled H2O, which is water, producing 6 volumes. Okay? You can do dilutions in 2 different ways. You can do a dilution ratio or a dilution factor. So you have to understand the differences here. So a dilution ratio is 1 to 10, 1 part solute or your concentrate to 10 parts solvent, which is your water. So you'll have 1 milliliter of sulfuric acid to 10 milliliters of DI water. That gives you 11 parts of a solution. Now again, the first number is the concentrate, the second number is the dilute or the DI water in this situation. So that's dilution ratio. Dilution factor, DF, you've got the 1 to 1, that equals 1 part solution to 9 parts solvent equals 10 parts of solution. So this can really make a difference with your math. So you have to understand what are they asking you to do, because it's going to affect how you do your math. Are you using a dilution ratio or a dilution factor? In the lab, there are different types of analysis. We're going to start with some of these basic types of analysis, not the test itself, but the different families of analysis. So a gravimetric analysis is a measurement based on mass. So your total suspended solids, your volatile solids, your total solids, these are all based on mass. Okay? These samples are passed through a filter at a given volume, dried, then weighed, then recorded as milligrams per liter. That's gravimetric. Now we also have titration and indicators. These are measurements based on color change. A chemical analysis that involves adding a standardized reagent to a fixed volume of sample and noting a specific color change. The volume of the standardized reagent is the variable that must be documented when the color change takes place. This reagent volume is proportional to the volume of constituent in the sample and can be used to calculate the concentration of the constituent. Care must be taken to accurately document the volume of sample and reagent used, or the analytical result will be inaccurate. Again, that was a titration. Now we're going to a colorimetric analysis. Again, this is a measurement based on color change. This is a chemical analysis that involves adding a standardized reagent to a fixed volume of sample. The volume of the added reagent is fixed. The amount of the color change is interpreted to determine the concentration. A colorimeter uses light absorption to interpret the color change and calculate the concentration of the specific contaminant, while a spectrophotometer separates the light waves into specific wavelengths. The wavelengths register on a photocell and then are turned into a proportional signal. And that is colorimetric analysis. So now we're going to light scattering. This means that it's a measurement based on light intensity. So a turbidity meter is based on light scattering rather than light absorption. So you're putting light through the sample, and the volume of light that goes through it is where you're getting your number from, your reading. Now we're swapping to microscopy, okay? This is you using a microscope. So microscope is used to optically verify microorganisms, both by type and by volume. The microscope uses light and multiple lenses to magnify the visual image. So you're going to use a microscope to look at the real small bugs or or microorganisms in your mixed liquor. Okay. Another type is probe-based instruments. These are instruments that are used in the lab and in your wastewater treatment process. Okay, so probe-based instruments have two major parts, the probe and the meter. The probe, that produces a voltage or current that is proportional to the constituent's concentration, the ion concentration. Probes will need to be serviced or replaced from time to time. The meter reads the voltage or the current and displays the results as a concentration. So that's what you are actually reading the number and recording the data off of, is the meter. If you've got instruments, if you've got meters, you've got instruments. If you've got instruments, you have calibration. All instrumental methods include a relationship between the sample conditions and the parameters that the instrument measures, such as voltage. This relationship can be adjusted by manipulating the calibration curve. In older instruments, this is a manual process. However, with newer instruments, the calibration curves are internal to the instrument and are software related. Part of the maintenance on these instruments can be probe replacement. If an instrument will not calibrate, the probe may need to be replaced. Now we're going to talk about records and data recording. Okay? The purpose of collecting samples and running the laboratory tests is to generate useful information. Therefore, it is important that this information be systematically and reliably recorded. Notebooks and spreadsheets provide a valuable record of your work that can be useful in diagnosing problems or identifying trends in plant performance. Record retention is also part of your discharge permit requirements. Laboratory quality control. Last but not least, you have performed all of your analysis, but are your results accurate? There are many ways that errors can develop. Instrument calibration, reagent failure, or contaminated glassware, just to mention a few. Some methods used in quality control are blanks. Blanks are clean water samples that are run through the analytical procedure. The results should be zero. Blanks are typically distilled or deionized water. External references, also known as certified references. These samples are available from the US EPA and from commercial sources. Your procedure should give the same result as the reference result. You've also got laboratory control samples. Okay, so a laboratory control sample is an in-house reference sample. It is created by adding a known quantity of a constituent to clear water. The known quantity is normally made from dry chemicals that can be weighed accurately. The analytical results should match the theoretical concentration calculated from the dry mass and the volume of water. So external references and laboratory control samples are very similar. The laboratory control sample is a mixture that the lab created. The external reference is a reference that was purchased from somebody else, but you're using both of them as a known. A matrix spike. All wastewater contains multiple constituents. Some of the constituents can cause interference with your analysis. A matrix spike is adding a specific volume of a constituent in question. Then, after analysis is completed, the known volume is subtracted to determine the unknown value. If the spiked volume is inaccurately measured, the calculation will lack accuracy. Duplicates are another means of quality control. Laboratory control samples and matrix spike duplicates should be ran periodically to check for things like drifting instrument calibration or consistency of technique. Sometimes field duplicates are also checked. These are made by taking a single sample and dividing it into 2 subsamples, then analyzing them separately, thus a split sample. Laboratory documentation. It is common for laboratory environments to focus heavily on documentation. You will find documentation telling you how to complete each task. Each lab technician will need to demonstrate proficiency with each procedure they use. Things that need to be documented daily include pH calibration, balance scale calibration, temperature in the lab, the sample refrigerators, the oven, the furnace, and the incubator. There is much more documentation besides these, but this is what I've brought up. The goal of this documentation is to reduce or eliminate variations in the laboratory process. If problems do arise, the hope is that you can review the documentation and resolve the issue. Okay? This is the end of my presentation on laboratories. Again, my contact information is on the right-hand side of your screen. I hope you found this interesting and informative. I hope you have a good day.